Welcome to another module of research methodology, determination of sample size. Sample size determination is one of the most important element of a research design using sample survey. What is sample size? Sample size is the number of observations taken from a population. So it is the number of elements taken from a population as sample. It is the part of the population chosen for a survey or experiment. So it is the specific part of the population or representative part of the population chosen for a survey. It is the subset of the population selected to make inferences about the population. So we are selecting the sample or this subset of population for making inferences about the population. So we are making inferences about the population from this subset of population or sample. Sample size must be adequate to represent the population. Larger the sample size, more accurate the findings from a study. Next, large and small sample theory. If the sample size is 30 or more, n is equal to or greater than 30, it is known as large sample. So if the sample size is 30 or more, we can consider it as a large sample. Then for large samples, the sampling distributions of statistics are normal. For large sample, the sampling distribution is assumed to be normal or Z distribution. If the sample size is less than 30, n is less than 30, it is known as small sample. For small samples, the sampling distributions are T, F and chi-square distribution. The value of statistics obtained from large sample can be taken as an estimation of population parameters. So the value of statistics obtained from large sample can be taken as the correct estimation of the population parameter. Then determination of sample size. Before collecting data, it is important to determine how many samples are needed to perform a reliable analysis. So the selection of a sample size is one of the most important consideration before collecting data. Sample size determination is the mathematical estimation of the number of population units to be included in the study. So it is the mathematical estimation of the number of population to be included in the study. Sample size must be adequate to represent the population. Then what do you mean by adequacy? The determined size should be optimum and has to be obtained by the scientific method. So the sample size selected must be optimum. Determination of sample size is an important element of every research based on sampling. What are the factors affecting the size of the sample? First one, nature of the population. If the population is homogeneous, fewer cases will be enough. That means if the population elements are of same kind, fewer cases or small samples will be enough. If the population is heterogeneous, large number of cases may be required. Second one, availability of resources. The resources available, including time and money, are to be considered before determining the size of the sample. Large sample may be taken if sufficient time and money is available. Otherwise, small sample may be taken. Next factor, type of sampling method. If the sampling method is restricted random sampling, small sample will be enough. In restricted random sampling, the total population is divided into different groups and sufficient number of samples are selected from each group to ensure representation of all. So in this case, small sample will be enough. In simple random sampling, more numbers may be selected to ensure representation of all. In simple random sampling, there is no such a group. So more numbers may be selected to ensure representation. Cluster sampling demands more sample while compared to stratified sampling. Then fourth one, degree of accuracy required. If highest degree of accuracy is required, size of the sample should be large. So if the sample size is more, then it ensure more accuracy. Next, nature of analysis. Sample size may be influenced by the statistical tools and tests a researcher plans to use for analysis. So sample size may be influenced by the statistical tools and techniques we plan to use for our analysis. Complex multivariate statistics needs larger samples. If we want to use complex multivariate statistics for our analysis, then larger samples may be required. Factors used for sample size calculation is the next one. Sample size is influenced by the factors used for sample size calculation, such as size of population, margin error, confidence level, variability, etc. These are the elements included in the formula used for the calculation of sample size. Let us analyze each and every one in detail. Factors or elements used in sample size calculation. First one, margin of error. The margin of error is a statistic expressing the amount of random sampling error in the results of a survey. That means how many percentage points your result will differ from the real population value. So it is the amount of random sampling error in the results of a survey. The margin of error decreases when sample size increases. The next one is the confidence level. It is the estimated probability that a population estimate lies within a given margin of error. An example of margin of error and confidence level. Company X conducts a survey on customers and finds that 50% of the respondents say its customer service is very good. The confidence level is cited as 95 and margin of error is 3%. This information means that if the survey were conducted 100 times, the percentage who say service is very good will range between 47 and 53%. That means plus or minus 3 most of the time. That means 95% of the time. So here the confidence level is 95 and margin of error is 3. It means that if the survey were conducted 100 times or 200 times, the percentage who says service is very good will range between 47% and 53%. That means plus or minus 3 from 50%. Most of the time, that means 95% of the time. That is the confidence level. Next, sampling variability. Sampling variability is the extent to which the measures of a sample differ from the measures of the population. The variance and standard deviation are common measures of variability. The greater the variance, the larger the sample size. Generally, the sampling variability is taken from previous studies or from the data of pilot survey. The next one, population size. If the population is finite and known, it can be taken as a factor to calculate sample size. Sample size is calculated differently for finite, infinite, known and unknown populations. Then what is an optimum sample size? The determined sample size should be optimum and has to be obtained by the scientific method. An optimum sample for a study may be defined as that sample which fulfills the requirements of efficiency, representativeness, reliability and flexibility. So those samples which ensure efficiency, representativeness, reliability and flexibility is called optimum sample size. The sample should be small enough to avoid unnecessary expenses and large enough to reduce sampling errors. So a sample should be small enough to avoid unnecessary expenses and large enough to reduce sampling errors. That means the sample size must be optimum. The larger size can lead to ethical concerns, time consumption, and financial wastage. Smaller sample size may cause misrepresentation, inefficiency, and insignificant result. Optimum sample size is required for the following reason: to allow for appropriate analysis. For appropriate analysis, optimum sample size is required. To provide the desired level of accuracy, optimum sample size ensure desired level of accuracy. To allow validity of significance test. Next topic, methods determining sample size. So let us analyze what are the methods used for the determination of sample size. First one, arbitrary approach. It is the rule of thumb method which specifies a fixed percentage of the population as sample size. Here a fixed percentage of the population is taken as a sample size. According to this approach, sample should be at least 5% of the population and 10% is the ideal one. Then second one, conventional approach. According to this approach, the average sample size of similar studies can be taken as sample size. So according to conventional approach, some of the similar studies are taken and the average sample size of these similar studies can be taken as the sample size of our study. Next, statistical analysis requirements approach. Here, the sample size is determined on the basis of the proposed statistical analysis considerations. Sample size is determined for the requirements of the proposed statistical techniques for the analysis. If we plan to use advanced multivariate techniques for our analysis, it demands more sample size. So, the sample size is determined on the basis of the proposed statistical tools. Then cost benefit analysis, all you can afford method. In this approach, sample size is determined on the basis of the availability of resources and benefits expected from it. Generally considered ideal for non-probability sampling method. So here the sample size is determined on the basis of the availability of time, money and the benefits expected from it. Last method is the confidence interval approach. It applies the concept of variability, sampling distribution and standard error of the mean. Number of formulas suggested by statisticians. It uses statistical formulas for the calculation of sample size and number of formulas are suggested by various statisticians. The following elements are generally needed to determine the sample size by using these formulas. First one, amount of variability of the population. Then desired accuracy, that means acceptable sampling error. Then level of confidence. Let us analyze one standard formula used for sample size calculation. This formula was developed by William G. Coran. The formula is n is equal to z square into pq divided by e square. Here n is equal to sample size. Z is equal to standard error associated with the chosen level of confidence. Generally, a level of confidence of 95% give us a Z value of 1.96. Then P is equal to variability or standard deviation. Standard deviation can be taken from the results of previous studies or from the data collected as part of the pilot study or pilot survey. Then Q is equal to 1 minus P. E is equal to acceptable sample error. So n sample size is equal to z square. Z is equal to standard error. Then into P Q. P is equal to variability or standard deviation. Q 1 minus P. Then whole divided by E square. E is equal to acceptable sample error. Look into an example of sample size calculation by using Coran's formula. Here, conducting a survey to assess how much customers are fully satisfied with the product and services. We want to select sample from the population. Assume variability P is equal to 0.5, then confidence level 95%, sampling error 5%. The formula is n is equal to z square into PQ divided by E square. Here the confidence level 95% give us a Z value of 1.96. So 1.96 square into P. P is equal to 0.5 variability. Then Q 1 minus P 1 minus 0.5, that is also 0.5 divided by sampling error 5%, that is 0.05. So 0.05 square. N is equal to 3.8416 into 0.25 divided by 0.0025. 0.9604 divided by 0.0025. So the sample size is 384. Then another formula to calculate sample size. If the population size is finite and known. This formula is developed by Slovin in 1960. Here n is equal to n divided by 1 plus n into E square. Here small n is equal to sample size. Then capital N is equal to population size. E is equal to margin of error. So n is equal to n. So the population size divided by 1 plus n population size into E square. E is equal to margin of error. An example of sample size calculation by using Slovin's formula. In a study, size of the population is 10,000. Here the population size is known and finite. Margin of error is assumed to be 2%. Sample size calculation formula: n is equal to n divided by 1 plus n into e square. Here the population size capital N is equal to 10,000. So 10,000 divided by 1 plus 10,000 into margin of error 2%, that is 0.02 square. 10,000 divided by 1 plus 10,000 into 0.0004. 10,000 divided by 1 plus 4, 10,000 divided by 5. So the calculated sample size is 2000 by using Slovin's formula. So as per the Slovin's formula, the representative sample size is 2000 out of the population of 10,000. Thank you.